Welcome to my presentation of translation. We will start with the ribosome complex, just chilling over there with three sites: the E site, the P site, and the A site. Their significance will be explained as we progress. We start with the arrival of an mRNA. And look what it has on it. These are called triplet pairs, base triplets, also known as codons. If you will notice, the start of it is AUG, which codes for methionine, and that is the only start codon in the entire genetic code. So, once the mRNA arrives, the ribosome notices that there's a start codon and it attaches on to the mRNA. mRNA, woohoo! When it starts, it immediately goes in to the P site. Then, a tRNA arrives. Those three things are the anticodon. I didn't write them in, but you have to assume that that's what it is. And each tRNA has an amino acid. So once the tRNA arrives, it attaches on to that base triplet, and the amino acid is right there. And it always starts with methionine. The start codon will always code for methionine, which is that amino acid. Okay, so then the next amino acid is chilling around. It comes and lands in the A site. And it has its very own amino acid. Then the mRNA moves forward, taking with it the tRNA, moving along the amino acid. Then the next tRNA moves forward and the amino acid. This is the E site, also known as the exit site. This is what the three sites are for. The P site is the primary site being in use. The A site is the active site where the incoming tRNA will land, and the E site is where the outgoing tRNAs will exit. At this point, these two amino acids get attached to each other with a peptide bond. Amino acid. Now there's a new incoming tRNA with its very own amino acid. Woohoo! So then this one gets kicked out. Wah! And this moves forward, taking along this tRNA and this tRNA, and that amino acid attaches to these other two with their very own peptide bonds. Oops, my signage is going everywhere. Then there's another incoming tRNA with its very own amino acid. Woo! And then again, once again, this moves along, attaching the amino acids with the peptide bonds, kicking this one out of here. This one moves forward, this one moves forward, again leaving empty the A site for the next tRNA. This process continues onward and onward and onward and onward, leading with one tRNA always leaving, one tRNA always arriving, and these ones constantly getting moved forward until there's a very long amino acid chain which becomes a protein. Now, when the final stop codon is reached, in this case I've used UAA. There are three possible stop codons: UGA, UAA, or UGG. Once any of them come up, the ribosome automatically knows that it's time to terminate translation. So once that happens, a huge, ugly stop sign, crumpled up paper here, comes in. No tRNAs in that spot anymore because that's UAA. There's no anticodon for that. It's actually a little big block thing which tells the mRNA to go away, and it tells the ribosome to separate itself, tells the tRNAs to go back into the cytoplasm, and the amino acid becomes a protein. And that's the conclusion of translation, where RNA gets turned into a protein.